This is a production of Cornell University.
Great. Thank you very much, Andy. And thank you to SIPS for hosting this discussion, and thanks to Rebecca for joining me in this presentation. We'll do this as a tag team where I will present first and then pass off to Rebecca. As Andy mentioned, a large group of us, I'll introduce the group in just a moment, produced an expert panel report with one of those just mellifluous titles that rolls right off the tongue: Socio-Technical Innovation Bundles for Agri-Food Systems Transformation. Deep breath. So the cover is there. This is available on the Nature website. It was the 2020 expert panel of the journal Nature Sustainability, and the exercise was coordinated and financed by the Atkinson Center. So our thanks to both the editorial team at Nature Sustainability and especially to the Atkinson Center team. So the core of the report was built out of a dialogue that lasted for basically a year. Early in fall, a number of us started pulling together some background materials, but we kicked off the expert panel in December 2019 with a panel meeting down on the Roosevelt Island campus of Cornell Tech. And from then we began deliberations as a group depicted around the edges of this slide that culminated in the December 2020 release of the report. So it was just under a year from start to finish, which in the midst of pandemic, I thought was actually rather good, that we managed to pull this off on schedule in spite of the massive disruptions caused that we couldn't, for example, come together in fall to work on the report together as planned, and that we obviously had to adjust content of the report to address issues raised by the pandemic. But the defining feature of this expert panel, I think, was the diversity of its participants, as Andy alluded to. As you can see around with the pictures around the border here, I mean, considerable diversity in terms of gender and race and ethnicity, but also diversity in terms of where people reside, the geography of their interests, diversity in terms of the organizations, their affiliations. We had donor organizations like the Rockefeller Foundation or the African Development Bank. We had venture capital. We had large-scale institutional investment houses. We had big companies like Walmart or Nestle or Pepsi. We had NGOs like the Nature Conservancy and Oxfam, lots of academics from around the world, and quite different disciplines. I'm an economist. Rebecca is a plant pathologist, plant breeder. We had people from the environmental sciences, the agricultural sciences, the social sciences, even law. So this was a real meeting of the minds in many ways. And that's, I think, the part that gives it a little bit of heft, is this isn't a narrow perspective. This is what a very active, well-regarded group of people could find common ground on. And among the key things that really need to emphasize, and at some level I can't do justice to a very long report. I encourage people to download it and read it, or at least read the summary that is also available. But this really starts from the need to keep in mind two different key facts that often get ignored by one camp or another in arguments around food systems transformation. The first is that agri-food systems innovations of our lifetime over the last 50 some years have had absolutely huge positive impacts on human well-being. So the graphic that I show here is from the report, just showing the change in the percentage of undernourished populations around the world in the red line, but perhaps most importantly, showing the blue mass, which is the population, the human population that gets adequate dietary energy any given day. And that population has been growing by 90 million people a year, 10,000 people per hour. So while we commonly will focus on the red line and how the prevalence of undernourishment has largely stalled, indeed it's begun to increase again in recent years and surely has increased during the pandemic, perhaps the most remarkable and unremarked upon feature of global agri-food systems is its extraordinary ability to expand the reach of people who are getting adequate dietary energy. And the reason why that is important is roll back 50, 60, 70 years. In 1968, Paul Ehrlich's The Population Bomb volume was a raging popular success. People were really concerned that we were heading for a Malthusian crash, that people were going to begin starving en masse because the world simply couldn't produce enough food to meet the basic dietary energy intake requirements of a rapidly growing human population. The world designed agri-food systems and agri-food research systems in particular to address what it perceived at that time as the big challenge: growing human populations that would not get enough energy to survive, and we'd have mass famine. Clearly, the world's agri-food systems have succeeded in meeting that challenge. They were designed largely around that. The CGIAR's first chairman famously talked about the purpose of the CGIAR was to grow the pile of rice available to food short consumers. Well, that has succeeded. So it's important to embrace that fact. It's equally important to embrace the fact that while the world's agri-food systems have succeeded in meeting the objective of providing adequate dietary energy for a growing human population, they have failed in other very important dimensions. There have been unsustainable spillover effects on climate and the environment. There are important social justice considerations with growing inequity in the system, with the extreme risk to which many farmers and farm workers and post-farm gate workers in places like slaughterhouses are exposed to. There are important public health and nutrition concerns around the food basket that is being produced, processed, distributed, and consumed. And so we must keep in mind both the successes and the challenges of the system, that we must embrace the possibility of success through innovation, as was ignited 60 plus years ago. Indeed, we must accelerate innovation, but we have to change the objectives. And that gets us to key conclusions of the expert panel. So the first is, we started by, let's define the agri-food system. And I emphasize agri-food as a somewhat clunky modifier because the system begins with the production of agricultural commodities, largely but not exclusively on farms or in fisheries. And those agricultural commodities get transformed into the foods we consume. Today, in a paper now forthcoming in Nature Food, 73% of consumer food expenditures worldwide represent value addition post-farm gate, value addition that happens in processors, in manufacturers, in wholesalers, retailers, restaurants. Most of the value of the food we consume does not originate in the farm, it originates post-farm. So we have to keep in mind that there's food on the end and there's agricultural practices at the beginning, hence the agri-food system language that we use to represent that there's a very complex web of actors and of processes, both biotic and abiotic processes. As we think through food systems, there are really four key features that the expert panel emphasized throughout this report. The first is, it is a system, but it is not a system that lends itself to optimization. There's no controller of the system. Rather, it is a system of billions of people who are individually making production, consumption, distribution decisions every day. And that means that if you can't optimize a system, you have to do what we economists call mechanism design. You have to design the rules of engagement, the institutions of the system, to induce people to make behaviors that are mutually reinforcing and generate favorable outcomes, that we expect will generate favorable outcomes. You can't just pull a lever and get everybody to do what you want. So human agency is really the key defining feature of all of this, that humans are the source of most of the problems in agri-food systems. We are also the prospective source of solutions, but inducing people to do the right things far more often than not is going to be the key to agri-food system transformation. The second crucial thing that one has to keep in mind is the heterogeneity of agri-food systems. There are no one-size-fits-all solutions. Even within a given location, what's right for one subpopulation can differ from what's going to work best for another. I'll come to examples of that in just a couple of slides. The third core point we wanted to make about agri-food systems is that spillover effects are pervasive. And hence you need portfolio approaches, what we refer to as socio-technical bundles, representing that there are going to be bundles of technical solutions based in bench science, as well as social solutions based partly on social science, but much on cultural issues and economic policy and on the political economy of systems. Spillover effects are pervasive in the sense that interventions that intend to achieve one goal invariably affect multiple goals at a time. As part of this project, a group of us produced a paper that published in the Lancet Planetary Health earlier this year, demonstrating how every single innovation we could identify targeted to achieving an SDG related to the food system. So, for example, improvement in germplasm intended to help reduce hunger consistent with Sustainable Development Goal 2, that has spillover effects on other SDGs. Indeed, every innovation would have negative spillover effects on at least one other SDG, predictably. So one has to think about the totality of impacts. Just because we're trying to reduce hunger, or we're trying to improve soil sustainability, or we're trying to preserve fisheries, we have to pay attention to there will be effects in other domains, hence the need for portfolio approaches. Finally, and this shouldn't be a hard sell for this audience, science is fundamental to innovation, especially in evolutionary systems. The pest and pathogen pressures are changing, the climate is changing. All of that means we need science, even just to adapt the things we already do. So together, these four key features of agri-food systems, which we summarize in the mnemonic HIS, you have to keep in mind that the agri-food systems are HIS, that they are characterized by these four attributes, but we must make them hers. And that is the next to the key conclusion. So the group set about trying to define what are our visions for, our objectives for the agri-food systems at a 50-year horizon. So 50 years from now, in 2070, what would be the defining features of food systems that we would celebrate? And we came up with these four key features that were not part of the defining vision of a food system that increases the pile of rice available for food short consumers, which is all about productivity, efficiency, and dietary energy. Here, it's about healthy diets. It's about a range of products available, healthy, safe to consume, providing the full suite of nutrients as well as non-nutritive features of foods, fiber, for example, essential to good human health. Second, they will provide equitable livelihoods where you don't have disproportionate catastrophic risk exposure to particular people who work dangerous jobs and are very poorly paid and commonly are indentured or enslaved. Third, there'll be resilient systems that can withstand pandemics and climate change, that can withstand political turmoil, et cetera. The changes in the world are increasingly rapid and consequential. Food systems have been under significant stress in the last year. Many of us think they've performed remarkably well, but how many more times can we subject them to shocks of the sort we've just gone through this last year without them breaking? And fourth, and perhaps most compellingly to many panelists, was the need for sustainability. The planet just cannot grow the food needed to meet future populations with higher incomes without changing methods of food production back to farm and post-farm gate. So we articulated a vision of agri-food systems as being hers in the future. And that future vision means that today we need to shift away from yesterday's objectives. But today we need to be looking forward. We need to look to what will be future states, not today's states. So the third key activity we did was defining the external drivers. What is going to change between today and 25 to 50 years from now? Not just to the SDGs, because none of the bench science being done in SIPs today is going to have impact at scale in the world by 2030. That's an unrealistic timeline. Agricultural R&D's payoff at scale occurs in the 10 to 30-year time window disproportionately. There are a range of studies demonstrating this. Indeed, publicly funded R&D begins to have its greatest impact starting at 15-year horizons and beyond. Not coincidentally, public research pays off beyond the traditional patent window. Private research pays off in a nearer term. So if you're looking for today's research that's going to impact the world favorably in realistic time horizons, that's 25 years out, 20 years out, even 50 years out in some cases. 50 years ago, we were talking about the first conference on RNA. We were seeing the emergence of the internet and email clients and operating systems. That's 50 years ago, 40 years ago. So we're talking about similar sorts of horizons. The key three things we identified that will define the changes necessary in agri-food systems between today and that tomorrow. First is climate change, for obvious reasons, because so much of it is baked in, and we've demonstrated such poor commitment as a species to shifting our behaviors to start mitigating climate change. We simply have to be prepared to adapt to it while still trying to mitigate. Second, population shifts. Basic demography is baked in populations that are going to grow around the world continuously in sub-Saharan Africa through the rest of this century. They'll peak sometime during the century in all other regions of the world. Indeed, are already peaking in Europe probably this decade. But the population will not only grow, perhaps most importantly, it's going to urbanize and it's going to age. So that means that we are going to be elongating supply chains, putting more demands on transportation, processing, manufacturing, and distribution systems. Workforces will be aging. We'll have larger populations of dependent elderly people than we do today. These all matter to how we design, how we try to tweak food systems. And income growth. We should be desirous of income growth in poor areas, in particular, where people suffer unnecessary poverty. But among poor populations, as incomes grow, their demand for food products grows very quickly, much faster than it does in the high income world. In economics, this is called Engel's law, that the income elasticity of demand for food, as it's termed, is much higher for poorer populations than it is for richer populations. The key implication of all of this really is that we must pay far more attention to Africa, where climate change is both going to be quite pronounced, but have some of its biggest impacts, where population shifts are going to be greatest. Africa will be the most populous region in the world by the middle of the century, and where income growth will be as fast as any other region of the world, but will have a much bigger impact on the food system because it starts from a lower base. The implication ultimately is that more than half of demand growth for food around the world between now and 2100 will occur in Africa. So we need to be designing, we need to be thinking about systems that are prepared to absorb massive changes in Africa in particular. The final key point of the report, before I get to the core essential actions, was we went through and we did an enumeration exercise, and we came up with a huge number of promising scientific advances that are at various stages of deployment readiness, from things that are still really on the lab bench to advances that are already out in farmers' fields and are being adapted in various agri-ecosystems around the world. This spans entire range of food value chains, from restaurant kitchens and individual consumer kitchens and dining rooms to farmers and the input suppliers and everything in between. And it varies across geographies. The problem is not adequate ideas and adequate new innovations. The problem is packaging them and evaluating them and directing them to where they can achieve the greatest impacts individually and especially as bundles of synergistic complementary inputs. So we see that as a system that requires dialogue. This is, again, human agency is at the heart of this. So we ultimately crafted this heuristic to represent a feedback system where innovation drives people to put together different pieces into context-dependent socio-technical innovation bundles. So bundles of different innovations, I'll give you an example in just a moment, that are appropriate to a context for solving a particular problem that can be implemented and scaled, and that feeds back into assessment of progress and re-innovation, adaptation. So that innovation cycle guides an awful lot of what our recommendations are about. The 7 essential actions we ultimately came down to, the key one is that you have to think about this as bundles. There are no magic bullets. There are no single technologies or single policies that will fix the problems we face, that will meet the needs that loom ahead. So we must bundle for 3 reasons. The first is there are really big synergies between different interventions. Think back to the progress made in the early rice innovations originating from Erie and National Agricultural Research and Extension Systems in South and Southeast Asia, IR8, IR64, et cetera. Those have had an amazing impact on the rice economy of the world. Now think about golden rice, which has been around for 20 some years. Golden rice is, if anything, just as remarkable a scientific accomplishment, although I defer to those of you who are breeders who can appreciate these issues better than I can. But golden rice is still not being cultivated in an open, commercially available way anywhere in the world. It is heavily regulated in the few places that have it in the field. It's not diffused in more than 20 years since its quite celebrated discovery. Why? Well, there are a whole host of reasons, but many of them are that there aren't the supporting policy and institutional infrastructure. IR8 and IR64 were rolling out at a time when especially Asian governments were building rural roads, they were working on land tenure, they were providing extension, they were developing irrigation systems, they helped with NARs that would help to adapt varieties to local contexts. All of these other innovations complemented the basic germplasm change. So those synergies are crucial. Innovations they're supporting innovations that are sort of like the backup singers for a good band. Second key reason for socio-technical innovation bundles is the need to address the political economy issues. As I mentioned, there is no innovation we could identify that we could not predict will have some negative spillover effect in some domain. So how do you internalize that? Well, you come up with some complementary intervention that is intended to address this adversely affected domain. So for example, when we think about germplasm, it's going to pull more nutrients from the soil to fill out larger panicles with higher yields, then we need complementary interventions to address the soil consequences of that. If you aren't replenishing nutrients in the soil that are now winding up in a greater harvest of grain, you're going to have a problem. So what are the complementary interventions to attend to the soil consequences of increasing yields? So that is a rather trivial example that you guys can appreciate more than others can. But at broader scale, as we think about things like the rise of fermentation-based substitutes for meats, the Beyond and Impossible and Omni substitutes, well, these are pulling production of food away from traditional farming with consequences for livestock producers, for feed grain producers, for rural landowners in places that depend upon feed grain and livestock production. That has big political economy considerations. So it's no wonder there's massive resistance to calling some of these products meat. Even cellular meat produced by tissue engineering that is as tissue identical to that taken from a slaughtered animal, there's a great deal of political resistance to labeling that meat. Why? Because you are threatening a particular constituency. How do you address that? You bundle things together. You attend to the needs of those constituencies. Without bundling, we invite political opposition to progress that is necessary. And finally, there are different needs, that there are rarely individual innovations that can attend to all the needs one has. So for example, the challenge of reducing micronutrient deficiencies in communities where many people don't get enough vitamins or minerals, a problem I know many SIPS faculty and students work on. This needs nutrition education to improve dietary choice. It needs school feeding programs that provide a more diverse, nutrient-rich diet. Those are policy innovations, but those aren't going to suffice. We know that because we try that in lots of places, and we often see some positive but very incomplete and ultimately unsatisfactory results. This also requires things like industrial fortification, which partly is a regulatory issue. Do you require that particular products be fortified with, for example, folic acid or iron? or do you require salt be iodized? Partly this is biofortification, improvements in germplasm so that they make bioavailable key minerals and nutrients. Putting all of those pieces together, like the puzzle pieces represented here, is an essential task of bundling of innovations to attend to the challenges that are going to vary by context. So hence lots of different puzzle pieces put together in different ways. Second key essential action is the need to reduce the land and water footprint of food. We simply can't sustain basing all production of food on the land. We're seeing that with the encroachment in wild areas and zoonoses, as well as climate change. So transitioning more rural lands from farming feed grains or even farming livestock to farming wind and solar energy and carbon sequestration and geothermal energy and habitat conservation, and beginning to produce more of our foods in vertical agriculture structures like the one depicted here in India, or in precision fermentation-based production of meat substitutes like this picture from Impossible's facilities out in California. That process of de-agrarianization, of decoupling the production of food from the land, from the agrarian process. Much like a century ago, we began decoupling the production of food from labor through the process of mechanization. So we have a very similar sort of substitution that is on the cusp of taking off now. Just as 100 years ago, many people had a hard time imagining turning machines loose on the countryside to produce most of our food rather than men and women with hoes and shovels and rakes. Today, it's hard to imagine lots of food not being produced. It's hard to imagine lots of our food being produced away from farms in factories in urban and peri-urban areas. But that is where we're heading. And we have to manage the creative destruction of that de-agrarianization process cleverly. We need to commit to doing this in partnership. So a lot of that is around agreeing to and articulating key performance measures, setting up safety nets so that people who fall between the cracks during transitions aren't worried about that they have the assurance that collective progress isn't going to have individual casualties. And penalizing, agreeing to penalties for those who break the social trust, who engage in activities that are harmful to others. So this is necessary. This is not easy, but this is necessary. And we have some examples of this proceeding. So the science and technology backyards innovations in China are a particularly exciting idea and a very powerful example that some of you are already aware of. So let me fast forward through these in the interest of time, because Rebecca is going to spend some time talking about what are the implications for SIPs and for Cornell more broadly. But let me just briefly flag deconcentrating power is going to be a crucial issue here. Again, political economy lurks in the background of most of this. We simply have too many people who can stall progress because they stand to lose. We have to think more carefully about systemic risk management. If COVID has made no other impression upon anybody, we hope that it is that there are big and growing systemic risks out there we must be prepared to manage, including in agri-food systems. We can mobilize tons of money. We've just appropriated in the United States $1.9 trillion earlier this month for COVID relief. We can mobilize huge sums of money very quickly, and investors around the world are looking for new places to invest. There are these huge speculative bubbles on sports cars and baseball cards and paintings, because lots of rich organizations and individuals have no place to put money where they think will earn a decent return. They're increasingly looking to innovations in things like agri-food systems. We just need to mobilize private resources to complement what can be made available through philanthropies and through public spending. That requires good measurement, because private dollars follow measurable performance metrics. Part of this is reconfiguring public support for agri-food systems. We have a farm bill that looms ahead in the United States. This is a tremendous opportunity for us to try to redefine in the United States, and thereby model for other countries, the need to put government in the role of investing in essential public goods and services and facilitating dialogue to find cooperative solutions and less in just wasteful, distortionary behavior. So much of the government spending in the agri-food system today is not especially productive. It's not investment in research and extension and key infrastructure and social protection. It's payoff programs to political friends. So with that, let me pass over to Rebecca and end my screen share because I know she's got slides. The website available through the Atkinson Center has all the products of the expert panel, including links to journal articles as well as to the report and its summary. So I thank you all very much for your time and interest. Let me turn it over to Rebecca.
There you go.
Great, thanks a lot. So thank you so much, Chris and Andy. And just to recap quickly where we've gotten so far. So Chris has gone over some of the pressures on the food system, some of the changes that are happening as a result of those pressures, such as climate change, demographic transitions, income shifts. What responses are needed to mitigate the inequalities and the food insecurity and the environmental degradation that's happening as a consequence? How do we get to that healthy, equitable, resilient, and sustainable food system we want differently in different places? And so the real question that I'm kind of wanting to get at is, what do us plant and animal scientists have to offer? So I will not presume to actually try to answer any of these questions. And, I'm terrified to address the last one. So what I'm going to do is more think of questions that are pertinent to us as SIPS members, and invite your questions. So I'll put mine out there. I'm sort of cherry picking out the bits that I found particularly interesting, and really hope to solicit the conversation. I think we need to live these questions. We need to have these conversations. I look forward to hearing your thoughts and reactions. Just to say that Chris mentioned this profuse pipeline of promising possibilities. And we had a team of wonderful undergraduate and graduate students who was supporting that expert panel along the way. And they scoured the literature before we even met and come up with more than 100 innovations, which is a cornucopia of apples, oranges, pears, car parts, policies, institutional stuff too. So they could categorize those innovations as agricological, biochemical, digital, mechanical, cultural, dietary, policy, and institutional. And then the panel sort of got together and discussed them, as Chris mentioned, at Roosevelt Island. We came up with a notionally smaller list and did a quick little vote, and then we got to writing as sub-teams on those topics, and then the situation took its own course. I guess I'm partly showing this to give respect, to hats off to the student team, the incredible wealth of innovations that are in progress, and consequently the paltriness of the list that I will personally be addressing here. I did kind of want to point out that the #1 voted topic was the circular economy of organic materials, and I was both surprised and delighted because that's one of the things that really captivated my imagination as well going through this. So at some point along the way, I did a quick mind map of the innovations that the student team had found out. And I just wanted to acknowledge that one of the longer lists on that area was digital agriculture. And just to say, I'm not going to say more about that, but to acknowledge that Cornell's got a very vibrant digital agriculture endeavor going on. And I just wanted to also point out that Rikin Gandhi is an amazing person who was one of our panel members who took the lead on this particular topic. And if you're interested in digital or you're not, you still might want to read what Rikin has put into that section. And I just wanted to note that he is giving a seminar in the Soil and Crop Science seminar series in May, so May 6th. So I would always recommend hearing him at any opportunity, but it's great that he's coming up. So he was a great panelist to work with. I will be touching on this issue of agroecology. And so the question here might be, what would it take to shift food production towards greater sustainability? And probably this one ought to be, this is that circular economy for organic materials. What would it take to turn organic waste, they're not waste if we don't waste them, into resources instead of pollutants? And really that, properly ought to be seen as a subset of agroecology, of course. Chris has already mentioned this idea of a radical change in protein production through fermentation. And another of our panelists was Ed Buckler, our very own, And we'd actually hoped to get him as a co-panelist for today's presentation. And since he wasn't available, I stole a few of his thoughts for this presentation, which I will acknowledge as I go along. So then the question is, if this big change is coming fast and soon and hard, what does it have? What are the implications for us as plant scientists and animal, and how does it affect the stakeholders for whom we do our work? Okay, so to the agroecology topic, there's been a tremendous amount written and said about this recently, or at least that's my strong impression, because McKnight Foundation program that Andy mentioned at the beginning that I've worked for a couple of decades now has that as its central focus. And so I somewhat track the increasingly large number of thought pieces, such as the report that we put together, that are talking about the need to put agriculture, whether it's subsistence, smallholder farming, or large-scale industrial agriculture, on a more sustainable footing. And so one of the thoughts is sort of relevant, related to what Chris said, that we don't want to just design pieces of the system and let the chips fall where they may. We actually have to think of entire systems. I think we're inclined and prone to breeding for or managing components of the system, but if we bring a systems view to it, we stand to improve the performance of entire systems through better soil biology, nutrient cycling, performance against the many climate-induced problems that slam our systems all the time, including the rapidly evolving pest and disease problems. And we stand to contribute towards the healthy aspect of HERS, the healthy and diverse diets that we increasingly are aware that we need. So when the subject comes up, it's often, well, yeah, that works, for smallholders operating tiny pieces of land, but how do you mechanize that? So what's the answer? How do we mechanize that? I suppose we can mechanize it if we want to. How do we scale it? I suppose we can do it if we want to. So thinking of how the idea of agroecology has evolved over time, this is a recent paper that included Cornell co-author Rachel Besniker in Global Development. So the timeline here of agroecological thinking goes from the 1930s towards the present. And of course, agroecology has been going on for all of time. But as a science, it sort of concerned itself initially with plot and field, and it's been getting more ample in its scope, from farm to ecosystem and to the ecology of the entire food system. It's taking on principles that are initially sort of more biophysical, agricultural, environmental, and increasingly social and cultural issues, economic and political issues. So if I think of, okay, so what's the question that I would pose here? So, as a person who works on pest and disease issues, I took this picture of a farmer in the Peruvian Andes. He's spraying fungicides, which are not necessarily good for you. It's the compound or whatever it is dripping down his leg. He's giving me this nice thumbs up while he's spraying his potato crop, which he probably does every week or every 3 days to keep it from being destroyed by potato late blight. So I think we long have recognized that it's probably not a healthy thing to hose down the planet with pesticides or potentially toxic compounds at regular intervals. But what would it take to shift from a global reliance on pesticides to the use of agroecological principles? I think a lot of us in SIPs have been working on the science of disease resistance or similar for many years, but the scientific findings themselves do not necessarily change practice. So it's increasingly recognized that agroecology has different spheres, particularly science, practice, and movement. And I think to the point Chris made about puzzle pieces, we can see the need to fit those puzzle pieces together to achieve the outcomes that we think are important. So, we can produce all the science we want about disease resistance, about multi-trophic interactions, whatever it is. But to really change practice, what does it take? We haven't been that effective. Do we need to team up with movement actors to pressure for the policies that would, for example, disfavor pesticide use and support agroecological principles? And it's been notable and unfortunate that the movement actors have preferred to focus on being an obstacle to the use of transgenic or gene modification technologies, and seem to give pesticide use a lot more of a pass than I think would be reasonable. So can we again work these socio-technical bundles more effectively? Can we get can we help, team up with science, practice, and movement to attain the changes in the agroecological level of the food system that we know to be so important. So moving on to a second sort of topic that I found intriguing and compelling, that's the idea of circular economy. So this morning I was on one phone call about Agricology. It was a funders group talking about how, what's the spending on agroecological science, practice, and movement from donor agencies, national, bilateral, multilateral. And then earlier in the day, I was on a phone call that was sponsored by the Ellen MacArthur Foundation on circular economy in New York City. Again, there was an interesting Cornell team that was also part of that conversation, whom I had never met before. Anyway, so the idea is how I'll say a little bit more about that concept, but the question here that motivates me is how can we contribute to developing what I might call the circular bionutrient economy. So I suppose people are familiar with this concept, but just to review, the idea of a linear economy is one that takes raw materials that might be mined or manufactured, produces stuff with them, we use it, and then we throw it away. So, we don't follow such an extreme view. We have some, recycling and reuse in our society, but we could go a lot farther to really making sure that we map through recycling, upcycling, repurposing, we keep materials in use a lot longer until we get something that might resemble this more circular economy. So what would that mean when we think about agriculture and we think about plant science? Well, first off, farming used to be extremely circular, and we still have that heritage to draw upon. But throughout my lifetime, there's been this, as Chris mentioned, this fabulous revolution where we were able to benefit from the wonders of the petrochemical fossil fuels, and we figured out how to manufacture nitrogen from fossil fuel, and we mine phosphorus. The use of those inputs, as Chris mentioned, has given us tremendous success in just multiplying global cereal yields, for example, by 2 to 3-fold. And that's come with a bunch of goods, but as Chris mentioned, a bunch of, and as we all know, a bunch of environmental problems, pollution, loss of soil or organic matter, eutrophication, harmful algal blooms, and so on, because of the fact that a lot of those fertilizers that we're putting on the land and that run through our bodies are coming out into our bodies of water, leading to this kind of mess that we have. So, and just an example is that more than half the energy that goes into taking a corn kernel and turning it into a corn ear comes from the nitrogenous fertilizer, again, that we make through the Haber-Bosch process, which is based on fossil fuel use. So how do we circularize? Well, we can look at all of the different organic waste that we have. They could be industrial, they could be yard waste, kitchen, market, including human excretus or waste before and after consumption. And the traditional recycler is the pig, and for example, in Chinese traditional agriculture. And one thing I learned that I really enjoyed from this panel work was that the black soldier fly is the new, micro livestock, the new or mini livestock, the new pig. It'll take really, market waste, human waste, and turn it into very high quality protein and fat, which is really considered to be essential for now making a sustainable fishery industry. Now, like a large fraction of the ocean catch is fed to farm salmon, and we can use we use this biochar. We can produce fish feed, poultry feed, food, and then return that again in a circular manner. So that's sort of looking on the micro scale. At the macro scale, how do we return that? How do we deal with this disequilibrium of nutrients? It's piling up in urban areas where all the people are, the food's coming to the city and piling up as pollution going into our water bodies. How do we bring that back onto the land? That's another whole question that we can tackle and work on. And that, I'm feeling excited to work on myself with colleagues in SIPS and elsewhere. So, to take such a thing forward, particularly the ecological sanitation, close the loop and transform the poop, we face a huge amount of perception challenges. There are technical issues. There are obstacles in terms of, sunk costs in sewers and in the way that we currently handle matters. So there's just enormous challenges of all sorts that are questions that we can live and take up and challenge over time. Again, a tremendous need to do these socio-technical bundling to accomplish actual change on the ground. Coming to the third topic here, I notice we're running short on time. I want to come back to the topic that Chris raised, this intriguing issue of de-agrarianization. Now, I think all of us in SIPS are pro-agrarianization, and yet we recognize that whether we like it or not, there will increasingly be this decoupling of food production and land, and to some extent, it's a great thing. Chris showed this, veggie production in India, such things. Also, this is the middle of Los Angeles, of super high-tech controlled environment agriculture, but it can also be low tech, rooftop, school garden. This is a company, an IPM, a pest management company that's growing for its employees a tremendous amount of food on a roadside basis. So it's a small enterprise growing huge amount of really healthy fruit and veg on that roadside of a peri-urban street. And so how much food will we be able to produce? This is an important question for me. Using some of those wastes that are now causing urban environments to be fairly disgusting, unwholesome areas, how much can we recycle those wastes and turn them into healthy foods for people that also can contribute to livelihoods as well as hygiene and well-being? And I think the most radical idea that I encountered from the experience thinking of socio-technical bundles that are relevant to our area was this one that Chris mentioned about microbial fermentation to produce protein. So this is an idea that Ed Buckler's given a lot of deep thinking to, and he gave a really great plant breeding seminar recently. So if you weren't able to see that and you're taking interest in that, you might see his unpacking of the issues on a recorded plant breeding seminar. But the idea is, the rationale is simple. Fermentation is just more efficient. Microbes are pretty damn efficient. They make great protein and they do it really fast. So you've got alt meat that's based on plants, on cell culture, but now could, in completely, separated from land entirely, we'd be manufacturing really inexpensive meat. And just to say that there's a lot of stuff in the discussion of the panel also about alternative feeds, using seaweeds, new crops like camelina, black soldier flies, other ways that we can, in fact, bolster the livestock industry. So I don't think the message should be too simplistic that we're out. There are a lot of money going out against the livestock industry, but there's a lot of things going for it as well. But just to look at this Rethink X graph showing the price of beef over time per kilo over these years, and you can see that they're projecting that fermented protein is going to be just much cheaper than cow beef really fast. And the cell-based protein is going to come along much more slowly. So, we might be looking at a radical shift in what we're eating just based on the price because of this. So I don't know if you buy that or not, be interested to hear your opinions, but in any case, it's going to have implications beyond, the meat industry. So this is just a figure showing what we do with corn. Every dot here is 25 million bushels thereof. And, we eat a teeny bit of it. We use a little bit for these different food items. We export some of it, we burn quite a bit of it, and we feed a huge fraction of it to animals. So if those animals are going to become much fewer, that's going to have enormous implications for crop production as well. So just to wrap up, so plant science, has a tremendous amount to contribute, and I'd love to hear more thoughts if there's a few minutes for discussion. How can we contribute specifically? I've mentioned a couple of things. I didn't really mention diversification and carbon sequestration as much as I could, but so per the observations that Chris made, we need to be working together with the other stakeholders to turn our science into actual change to create a new and better future that we can have. Viewing this report gave me a lot of hope and inspiration for how we can do better. I want to say I really appreciated working with all the panelists, and hats off to my amazing chair, Chris Barrett, who's a force of nature and always a thrill and delight to work with. But I would love to work, think more with my fellow members of SIPS too about how can we contribute? What do we have to do to make these contributions real? Over.
Thanks a lot, Rebecca and Chris. That was wonderful. There's monitoring the chat here. We're a little bit over time, but if you guys would permit a couple of questions, I'm sure the floor has a few things to ask you. Someone has their hand up. Marvin, please go ahead.
Yeah, did the group consider anything about the effect of plants on human well-being beyond food? Think about green space and their ability to be involved in that recycling process, flowers, things like that, that we work on in plants, but it's not something that we directly consume.
Great points, Marvin. At a first order approximation, no. So there's a little bit of passing discussion of the value of green spaces and of active participation in food systems. People just get enjoyment out of this. But the focus of the group was very much on satisfying global food needs without thinking about other human needs or other gains. So excellent point.
Although I would also say, Marvin, when I think about that issue of urban and peri-urban food production, sort of de-agrarianized in the sense that you might be growing stuff not on the land that you own as a farm. For me, a really important point is the idea of beautification of the idea of giving people that the beauty of plants. So for me, when I think about my straw bale gardening schemes. And sack-based gardening, it's in part trying to think of how can we make this beautiful, how can we make it appealing to give people that psychic relief that I think they really need in those bleak, difficult environments. So thank you for that point.
Yeah, I think the panel is very sympathetic to your point, but it doesn't feature prominently in the report.
Hi, great presentation. I enjoyed it. What insights can you share with us about this non-agrarian farming, this vertical farming? Is it promising for its impact on the environment and its use of limited resources? Is the ecology of that highly favorable in comparison to the agrarian systems right now?
So great question, Gary. Like absolutely every other innovation we talked about, there will be negative effects from it.
Right.
I hope that's one of the key takeaways people took from the work that we did in this report. There are no solutions that generate only gains in some dimension and nothing bad in another dimension. So you need offsetting things. In the case of vertical farming, it's remarkable how fast it's changing. This is now a profitable venture in Asian cities. I mean, there are a bunch of companies, many of them from Cornell alums, as it turns out, who have got startups that have turned a profit within a couple of years and are providing high quality greens and berries to urban and peri-urban consumers, and not just the elite, not just rich people paying a premium. A lot of this is improvements in solar energy production. The price point on panels has come down fast. Improvements in indoor water distribution and heat regulation. So a lot of the adverse energy effects that have long been associated with vertical farming are coming down quickly. But it's obviously more energy consuming to not use the sun directly. So it will always be more efficient in terms of how we convert solar energy into calories in plants if the sun directly grows the plant rather than you have to intermediate. So there is clearly a loss there. The question is, can you compensate for that with gains in other places where you can then wind up generating an aggregate gain, including better energy use and reducing carbon footprints despite less efficient energy use.
Thank you.
Thank you, Gary. Thank you, Chris. Christina, you're next.
Thank you for presenting this work. It's great to hear the examples that you mentioned of startups that are using scientific knowledge and creating things that are beneficial. You also mentioned how some people have way too much money and they're doing things like buying $100 million electronic images. So given that there are a lot of people with money who have no ability to distinguish between what makes sense and what doesn't, what measures do we need in place, and what can we do so that people with absurd amount of money aren't defining what the best path forward is and aren't sort of creating so-called solutions that don't actually respect what people need, or also aren't supported by the science?
Yeah, so I'm feeling you and I agree on this at a fairly deep level. I guess the reason I throw that example out is it is so absurd, and your example of electronic images is an even better one than baseball cards. What's the intrinsic value of these things? It's got to be trivially small. So people are just engaged in sort of hobbies here, but in many cases they really are trying to make money. And they're trying to make, those that are trying to make money. I don't claim all are. We should interpret this as they are starved for places where they can invest their money, where they think there will be gains and they can measure them and capture them. And this is part of where some of the advances in digital technologies offer so much promise. Because we know, for example, that consumers are prepared to pay for lots of attributes of foods, sustainability attributes, health attributes, even social justice attributes, if they have confidence that they're not just, subject to marketing gimmicks. If you can verify attributes of food. As we begin to develop the ability to cost effectively demonstrate, was there really deforestation in the area from which this palm oil originated that's in this product, people are willing to pay a premium for that. Right now, you pay for certifiers, and the cost of certification in most cases exceeds the premium consumers are willing to pay. In some ways, this is like the problem of solar power, which for years was a great idea, but way too expensive to implement at scale. As digital technologies are making it increasingly feasible to come up with really low cost, credible verification of producer claims about products and their origins, we're at the cusp of unlocking some of the ability to mobilize the funding that many of us are willing to put into paying a little bit of a premium for our products. And that market is big. There are investors ready to go into this heavily, but right now it's not measurable. So we're probably not far away from that, but investors are really quant-oriented people. They need to be able to see what will trigger a payoff. When we get there, I think we'll stop seeing quite so much frivolous investment and a little bit more mobilization of funding for some things that I think a lot of the community on today's call cares about.
Thank you, Christina and Chris. Mamadou, you're next.
Hello, everybody. Thank you, Chris, for the presentation. Rebecca, good to see you. Chris, thank you for connecting with those alum who are doing a great job in India. Appreciate the email. I guess I'm going to just take up on what you just mentioned now. Like one of the limitation, it's really funding. We know the big part of this system for this innovation to work is not really the electronics. All those are cheaper now. It's mostly the solar, as you mentioned. Several years ago, it's been there and it's been there for long. It's still not affordable. Of course, the price of solar has decreased tremendously over the last 10 years. I guess I'm trying to do a parallel between what happened in the last 20 years. 1999 to today, about 22 years ago, we're talking about livestock revolution. It was a big talk. We're just saying, and that was driven by what? By income, by middle income increasing in the world. And we're more concerned about the environmental impact of that. Now we're talking about great innovation, great inventions, and what actually, to me, and of course, this is very early to say, to me is something that actually will be helping into leaving some lands able to generate, will be actually having more positive impact on the environment, agroecology, as Rebecca mentioned, and all that. But still, this thing, I'm wondering, is it going to take 20 years again for funding to be available? What do you think are the limitations for this to go fast? Because there is really, because I'm working on it already, there is tremendous opportunity, not only for people who are trying to make money, but people who are trying to just make more food and income available for those who cannot afford it, and access to better food. Right there in the middle of cities, right there doesn't require much of land. What will be, how to make funding go faster?
Yeah, so the section in the report on innovative financing, which I would encourage you to go check out, was an important contributor to that text was another Cornell alumnus, Andrew Mude, a Kenyan who's now at the African Development Bank, where a big part of his responsibilities at the African Development Bank are mobilizing private capital for investment in Africa's agri-food sectors. So everything from input suppliers, folks like the Hello Tractor and other Cornellian startup, those sorts of ventures that just need startup capital, to downstream processors and restaurants and co-ops, community supported agriculture movements that are trying to get onto digital platforms so that people can subscribe much more easily. All of these sorts of ventures fall within Andrew's remit, and he's involved in a lot of really exciting discussions. There is a lot of capital sloshing around there, but it's hard. This is, as much as many of us like to make fun of bankers and how horrible they can be in their stereotypes, they play an important role. And if they can help find the money that is going after frivolous investments, that's buying digital images, that could better spend $5 million investing in your startup working in the Sahel, Mamadou, that's the role that Andrew and others like him are trying to play right now. So I would encourage you, read the innovative financing instruments section of the report and follow up with somebody like Andrew, who's really doing it day to day.
Yeah, good luck.
You know what I will do? Thank you.
Great. We can leave the channel open, but I think we ought to close the meeting now since we're 15 minutes over. And Chris, Rebecca, thank you so much. A delight having you both here. It was really very thought-provoking, excellent presentations. Thank you so much.
This has been a production of Cornell University, on the web at cornell.edu.